So, how many of you yesterday when you were doing the homework, you got negative angles? If it's only one, that means there's something not right. If you either did not do the homework.
Yes, that's why. That is, you know what to do.
You either did not do the homework or
I did something wrong.
no, you did not do something wrong. You should be getting some negative answers. Okay, what was the question? So I want you to go to your homework, page 19, and go to question 6, page 19, 6B. 19 might be behind the other one. Okay, 6B. Can you guys do that on the calculator?
Sorry, I did it, but I couldn't.
Okay, so it's asking you to find angle A if tan A is negative 0.72. So question page 19, number 6, B, tan A is negative. Okay, and then what do you do to find angle A? So you do tan inverse, because anything an angle, you have to do the inverse, right? And then when you do tan inverse of negative 0.72, what do you get? Negative 35 degrees, or 36. 36. All right. I want to make sure that everyone's getting that answer. Okay? Now, page 19. So negative 36 degrees. All right. Now, can I report my answer to negative angles? No. Have you ever heard anyone telling you, draw a triangle with a negative 30-degree angle? No. Cut a piece of wood with a negative 500, whatever the angle is. No. Okay? So we always have to report our angles to positive degrees. Okay? Now, what does it mean that it's negative 36 degrees?
It's more than 90.
Yeah. It's more than 90, but why is it negative 36?
No, because it's in what? Second quadrant.
Second quadrant?
Well,
More, third, you said no, third or fourth?
Okay.
It's down.
So let's see. Okay.
Third or fourth, sorry.
All right. Let's look at this. So these are my X and Y, okay, or my main axis, okay? Now, when I'm measuring an angle, right, there should be a rule, right? Where do you start from? Where do you end? Okay? So you always start measuring, unless you're talking about bearing measurement. Okay, bearing measurement, we talked about that yesterday, and we said the bearing measurement has to start from the north and then clockwise. Do you guys remember that? So that's the bearing measurement. But when I'm talking about regular angle measurement and not bearing, okay, we measure
From the right to the left.
we measure from the x-axis, the positive x-axis. What is it called? Counterclockwise. Thank you. I'm just trying to get the word. All right. So if I'm measuring an angle, right, I have what we call a terminal arm. Okay. So I'll have my terminal arm. This is called terminal arm. Okay. You will need like a piece of paper for this. All right. To write this down. And then my angle measurement is going to be from the positive x-axis to the terminal arm. Okay?
Sorry, what is called again? You said?
Counterclockwise.
Contra.
Counter.
Counter.
measuring the angle from the positive x-axis counterclockwise to the terminal arm. Okay? Any terminal arm in the first quadrant, so this is my quadrant 1, okay? This is quadrant 1, this is quadrant 2, this is quadrant 3, and this is quadrant 4, okay? Any angle in the first quadrant, it's going to be between angle 0 and angle 9, okay? Because you see that they're going to form a perpendicular line, right? So they're going to form two lines that are perpendicular to each other, which means it's going to form a 90-degree angle, okay? Now, in the second quadrant, okay, so if I have a terminal arm in the second quadrant, right here, my measurement is going to be from the positive x-axis to the terminal arm again. Okay? Now, what am I expecting my measurement to be? Between what and what?
90 to 180.
Between 90 and 180, right? So in the second quadrant, my measurements are going to be somewhere between 90 and 180. Okay? Because this is my 180 degree. Okay? Now, again, I'm measuring from the positive x-axis counterclockwise to get to the terminal arm. Are we okay with that? Now, what if my terminal arm is in the third quadrant?
So 180 to 270.
That's right. So my angle measurement is going to be between 180 to 270 degrees. This is where the 270 degrees is. Remember that the lines are going up by 90, right? 0, 90, 180, 270, and then back to 360. Okay? That forms a full circle. And the circle is 360 degrees. Okay? Now, if I have a terminal arm in the fourth quadrant, so if I have a terminal arm in the fourth quadrant, my measurement is going to be between 270
to 360.
and 360, right? Because going back here, I'm going back to the x-axis line, and that's going to be 360. Okay? So it depends on which quadrant your line lies in, then your measurement is going to be between the two angles, okay? Between 180 and 270. But remember that we're always measuring from the positive x-axis counterclockwise. Okay? Now, if someone tells you your angle is negative 36 degrees, as the calculator just told you that your answer is negative 36 degrees. Okay? Negative is the opposite direction. Okay? If all of my angles going counterclockwise are positive, okay? So if I'm moving the other way, so if I move if I'm measuring the other way, okay, so if I have an angle in this quadrant and I'm measuring clockwise, I'm moving in the opposite direction of what I should move to, okay? So what would that be? Instead of being like between 0, it's going to be negative 9. That's right. Because now I'm moving clockwise. Okay? So my negative 36 is right here. And it's negative 36 because I'm moving clockwise. Okay? You see the direction of my measurement? You see how I'm going from the x to the terminal arm? Okay? That tells you that it's going clockwise. And then because it's going clockwise, you know that it's going to be a negative value. Okay? And if this is 0, then this is going to be negative 90. What would this be? Negative 180. What would this be? Negative 270. And then this is going to be negative 360. Okay? Now, can you leave your answer as a negative answer? No. You're going to have, are programmed, right, in a certain way. And then usually if your tan is negative, so as we did right here, right, tan is negative, it's going to give us an answer in the fourth quadrant. So it's going to give us an answer here, but negative. And we can't report that. We have to report it as a positive. Okay? I'm going to explain to you why is that, but just bear with me. I told you this is going to be like one of these nice heavy lessons. Okay? So how do I find this angle in the positive? So how can I find the measurement, right? Because remember that my actual measurement, the positive measurement, has to go from the x-axis counterclockwise, right? How can I find this actual measurement? Subtract it from 360, right? Why am I subtracting from 360?
To find so all over 360.
That's
so
right.
find
The whole circle's 360, right? If I want to remove this from it, right? So I have 360, and then take away the 36. Okay? So to find the measurement in the positive, you're going to do 360 minus 36, and that's going to give you the answer. Okay? Okay? Now this is what I want you to do. Try for me tan 324. No, it should be negative.
Yeah.
What is it? Negative 0.7 something?
Yeah, negative 0.7265.
Yeah. Is that what we had? Is that what we had here? Yeah? Yes. But remember that we had to round this angle too, right? This angle was not actually 36. This angle was actually 35.7, whatever, right? So when you start like rounding, your things are going to be a little bit off. They're not going to be exact, right? Remember that. Okay? So the actual angle measurement is 324, and this is what you have to report. Okay? You can't report your answer as a negative angle. Okay? Now, what we're going to learn today, we're going to learn the reason why in quadrant 1 and quadrant 2, right? Or I should say that. We're going to learn why cosine is negative for obtuse. Remember that from yesterday? Cosine was negative for obtuse. And what else was negative for obtuse? Tan. Right? We're going to learn why cosine and tan is negative for obtuse and why sine is positive for both obtuse and acute. Okay? So we're going to learn why today. But before I teach you why, I want to talk about a few different things. So what we learn in this course specifically, we only learn the first two quadrants. Okay? We don't get to the third and fourth quadrant. Okay? So we only learn what happens in the first two quadrants. When you get to the U-level courses, you learn about all four quadrants. Okay, what happens there. Now, looking at my quadrants, so you have the X and you have the Y, right? In the first quadrant, describe the values of X and the values of Y for me. Are they positive or are they negative? In the first quadrant, both are positive. So the X values are positive. Come on. Okay. There you go. And the Y values are positive. We know that, right? So in quadrant 1, both the X and the Y both the X and the Y are positive. How about in quadrant 2? Good. So the Y is positive, the X is negative. And in quadrant 3, so the x is negative and the y is negative. Quadrant 4,
X is positive, Y is
x is positive, y is negative. Do you think this has to do, so the x positive, x is negative, y is positive, or y is negative, do you think this has to do with anything when it comes to sine of something, cosine of something, and why they're positive or why they're negative?
Well, it depends on the size because of the direction it's pointing to, and the angle because of where it's standing at.
So where the angle is,
Yeah.
right? And, but what does it have, like, yes, but at the same time, I want, like, look at quadrant 1. What can you tell me about quadrant 1?
The all are positive.
negative.
All sides are positive, right? The x is positive, the y is positive,
I mean,
right?
sine is
What did we learn yesterday? And then in the first quadrant, my angles are between what and what?
0 and 90.
0 and 9, right? My angles here between 0 and 9.
It's acute.
0 and 90 is acute. Yesterday, we learned that all acute angles, what's the sign of any acute angle? Positive or negative? Cosine of acute. Tan of acute. Positive. So all sine, cosine, and tan of acute angles is going to be positive. Now check here. My x and my y are positive in the first quadrant. Okay? Now, let's look at the second quadrant. Sine is positive, cosine and tan were negative, right? So do you think there's something to do with x being negative? Let's see. All right? Keep in mind that what's positive, what's negative in quadrant 1 and 2. Okay? Let's go to the lesson. All of this and we haven't started the lesson.
I answered the same question.
All right. So, an acute angle is less than 90. We got that. Perfect. And then obtuse angle is between 90 and 180. Just please, guys, keep in mind that we're only going to be dealing with quadrant 1 and 2. Okay? If you decide to watch things that, videos or whatever that's meant to the U-level courses, you're going to see them also working with quadrant 3 and 4. But for this curriculum, it's only quadrant 1 and 2. Supplementary angles
180.
are angles that add up to 180. Okay. Now, we talked about this. So in the Cartesian plane, the intersection of the x-axis and the y-axis create 4 regions. And then they're called quadrants. And they're numbered counterclockwise starting from the upper right. So we talked about this, and we said this is quadrant 1, quadrant 2, quadrant 3, quadrant 4. Using the origin as one of the angles, any triangle can be defined within the first 2 quadrants, since any angle in an oblique triangle must be less than 180. Okay? So what they're saying is that no matter what we do for a triangle, right, any angle that I'm going to draw in a triangle has to be less than 180 because all 3 angles should equal to 180. Okay? Now, so this here gives you the x and y, like a point, a general point. I'm going to add to that general point, so I'm going to add some numbers, because adding numbers make you kind of see the example, okay? Letters sometimes, they get confusing, okay? So I would like to add some numbers to this, all right? Now let's read the first question. So the first thing is to define trig ratios on a coordinate grid using x, y, and r. So before we started with the coordinates or with the quadrants, sine is equal to what? Opposite over hypotenuse. Okay? And cosine? It's just this is becoming, this is deciding to be a little slow today. And tan is? Now, what we're trying to do here, we're trying to figure out these formulas, but instead of using opposite hypotenuse, opposite adjacent, we're going to use x, y, and I. Where x and y, they're your point. They're the value of the x and the y for your point. Okay? Well, once I give you the example, you'll know what I'm talking about. All right. So, here is my x and y axis. So I have a point x, y, and it's in quadrant 1. Okay, that's what the question's saying. Point x and y is in quadrant 1. Give me a point in quadrant 1. Just any value. 3 and 5?
Sure.
Okay. Is that what you said? I don't know what you, I heard something. 3, 5. That's what I heard. Okay. So I have the point 3, 5. Okay? So, 1, 2, 3, 1, 2, 3, 4, 5, and my point is right here. Okay? And this is 3, 5, which is x and y. Now, I located the point in my quadrant, right? I want to find the measurement of angle A, or I want to find the trig ratio of angle A. Okay? So I have to draw a triangle. I can't just have a point, right? Your triangle is always going to be drawn from the origin to the point, okay? So you're always going to start with drawing a line from the origin to that point. And then to finish your triangle, you're going to always draw a line going down to the x-axis, okay? So we always draw our triangle going down to the x-axis. So you see how I have now a right angle triangle. You see that? And this is my right angle right here. Can you guys see that? So, it's always the case where you have to draw that vertical line coming down to the x-axis. Either to the here, or if we're in this quadrant, it's going to go down here. Okay? So angle A is measured from the positive x-axis to the terminal arm, right? That's what we learned. So this is my angle A. Now, let's define the sides with respect to angle A. Where's the opposite? It's this one, right? The 5. Okay, so this is my opposite. Okay. Where is the hypotenuse?
Is it down?
It's the line from the origin to the point, right? So that's my hypotenuse. Okay. The terminal arm, yep. And then my adjacent is? Okay. So I have this. Just for those of you, I know it's hard to see, but we have this, right? Where this is my point P, which is 3, 5. This is my angle A, okay? This is the opposite. This is the adjacent. This is the hypotenuse. Now, what's the measurement measurement of the opposite?
5.
5. What's the measurement of the adjacent?
3.
What's the measurement of the hypotenuse? We don't know it, right? Can I find it?
Yeah, sure.
What do I do?
The hypotenuse. Yeah.
Pythagorean theorem. Okay? So the first step is I need to find the Pythagorean theorem. Now before we find the Pythagorean theorem, eyes on me, please. If I'm looking at the adjacent, how can I define the adjacent with respect to x and y? What's the adjacent with respect to my x and y? So it's the x value, right? So you look at the adjacent, that's the x, right? So this here also represents my x value, okay? How about the opposite?
The y value.
It's the y value, right? The opposite is your y value, which is 5. So now you see that instead of calling them adjacent and opposite, right, I can call them x and y. Okay? Now, they call the hypotenuse r. And the reason why they call the hypotenuse r is because, technically speaking, what we're trying to do here, we're trying to draw a circle where the origin is the center of the circle, and then you can draw a circle that passes through this point, right? So this becomes the radius of your circle. That's why they call it r. Just remember they call it r, okay? Now, if I want to find r, I can do r squared equal to x squared plus y squared, right? Which is the Pythagorean theorem, right? A squared plus b squared equals c squared. In this case, I'm using r squared equals x squared plus y squared. Yeah? Any questions about this? Now let's do the math. X is 3, so I have 3 squared plus 5 squared, which is 9 plus 25. And that's going to give me, what, 34? And then to find r, it's going to be the square root of 34, which is
5.8.
okay, can I leave the square root of 34? Or 5.8? Okay, why did I write 35? All right. Now, if I want to define sine A, what would sine A be?
19
Y over R, because sine is opposite over hypotenuse, right? So if I'm looking at sine A, it's opposite over hypotenuse. The opposite is Y, the hypotenuse is R, so that's Is it always going to be the case? Yes, it is. It's always going to be y over r for sine the angle. How about cosine? Adjacent over hypotenuse, which is what? X over r. And how about tan? So that's opposite over adjacent, y over x. So you see how I changed it from SOHCAHTOA to x, y, and r. Right? So now, if I know a point, I can find sine of the angle, cosine of the angle, tan of the angle, without even having to draw the triangle. Because I know that sine A is going to be y over r. So I have to find r, right? And then I can do y over whatever the r is. Okay? So cosine A is x over the r. Again, I know my x, I can find my r, and then I can do it. Okay? Without even drawing. So I can find the opposite and adjacent and hypotenuse. Okay? Now, let's do the math. What's y over r here? So that's 5 over 5.8, right? X is 3 over 5.8. You guys know where I'm getting these numbers from? Everyone? And then the other one is 5 over 3. Now, if you take any ratio and find the angle A, you should be getting a very, very similar answer, right? Now, mind you, if you use square root of 34 instead of 5.8, you will get the exact answer. Okay, everyone will get the exact answer. If you use 5.8, you might find it a little bit different just because we rounded. Okay, so this group, I want you to, the 4 of you here, I want you to use sine to find the angle for me. Okay, the back row, you're going to use cosine to find the angle for me, and then you guys are going to use tan to find the angle for me. Okay, you guys did 10. So since you did 10, I need an angle from the 10. 59. So if you did 10 inverse, you got 59. How about you guys? The one did sine.
Sine is 60.
You got 60. How about you guys?
59.
59 point?
So 58.85.
58 point, so that's 59. Okay.
Well, 0 is not 0.
Yeah, so
Who's did sine? They did sine? Can you guys do sine again?
but I didn't use 5.
You use the square root. Okay, there you go.
So we have for this number, right? 5.
Yeah. Okay.
Choose 3, 4.
Okay, you see how you guys, you got like almost the same answer, but it's not the same answer.
Sine is 6.
Okay. Now, eyes on me. Eyes on me. If you use this one, you kind of got 60. If you use this one, you got like 58.8 or something like this, which is about 59. If you use this one, you got exactly 59, 59.0, something like this. Okay. Now, these are they're similar answers, but they're not exact, right? The reason why you got 60 because it was 59.5, right? So you had to round it up to 60, right? The reason you had to round up to 59 is because it was 58.8. Now, here's what I want you guys to do. The sine and the cosine, instead of using 5.8, I want you to use the square root of 34.
Would have the same.
So I want you to use the square root of 34 here. What did you guys get?
59.
59. How about the cosine? What did you guys get?
Yes, 59.
59. How about the tan? What did you get? 59. So the reason why at the beginning we got a little bit different answers is because we rounded, right? We rounded earlier, so that rounding is going to affect our answer. Okay? That's why I said, I'd rather if we keep it as the square root of 34, because I'm not rounding here. Okay? So if you want exact answers, okay, you want to try not to round until the end. Your final answer is the answer that you want to round. Okay? So, it doesn't matter which ratio we used, right? Doesn't matter which one I used, I ended up with the same answer. I ended up that angle A is 59 degrees. Okay? Now, which one do you think will give you the answer without doing any work? 10. Because I don't have to do odd, right? I already know x and y, right? 10 is the one that's going to give you the exact answer. Right? Okay? Because x and y, they're already given to me. I didn't have to look for anything else. So I know that I haven't done any mistakes, right? Because sometimes when you're finding odd, you might make a mistake. You might do minus instead of plus, or you might, I don't know, forget to the square root, or you might forget to square. I don't know, right? So this is where you know that if you want to check your work, this is where you're gonna check your work. Okay. Now, another thing that I want you to look at. Sine A was 5 over square root of 34. Cosine A was 3 over square root of 34. Tan A was 5 over 3. Are they all positive? Yes. Was it a surprise to you that I'm in the first quadrant and they're all positive? No. Did we expect that? Yes. Is my angle acute?
Yeah.
Yes. Okay. So all of these things you guys have to think about. Okay? You have to think about these things when you're solving. What quadrant am I in? Sine and cosine and tan, are they all positive? Right? Okay, perfect. So my angle is going to be acute. Okay? Now if you look here, odd, no matter what, odd is going to be positive. Right? Because odd is a squared number and then you have to square root it, it's going to be positive. No matter what, odd is going to be positive. Okay? In the first quadrant, is y positive? Yes. So positive over positive is going to give me positive. Yes? Okay. In the first quadrant, is x positive? Positive over positive is going to give me positive. In the first quadrant, is y and x positive? Positive over positive is going to give me positive. So you see why all of them are positive. Okay? All right. So, any questions about this? Yeah? So 3 squared plus 5 squared because I used the Pythagorean theorem. Okay, because I'm looking for the hypotenuse. So I square the other sides and add them. A squared plus b squared equals c squared. And then you square root at the end. Okay? Any other questions? Okay, so we're going to take a quick break and then we'll come back. All right? 5 minutes.